Previous days, we've talked about solving quadratic equations. And again, if you don't remember, quadratic equations look just like linear equations, except for they have an x squared term. That's what makes it quadratic. You take the rest of that quadratic equation, it's a line. You add an x squared term to it, all of a sudden that line bends and turns into what's called a parabola. First method of solving quadratic equation, we talked about if you're missing that x term, you can simply move everything over, take the square root. If you do have an x term, we try to factor. That's always the easiest way to solve if you have an x term. Next method, we actually use completing the square, which is not very much fun. And then the last method, used mainly, again, if it's not factorable, this is the way to go. Okay, called the quadratic formula. All quadratic equations, I wish I hadn't erased that. Let's go back. All quadratic equations have an a term, where that a could be, let's see, whatever. It just can't be 0, because if that a term is 0, all of a sudden you have linear. You have a b term, and you have a c term. Number one mistake, just make sure is when you're plugging this a, b, and c into this formula, don't plug in the x's with it. You're just looking at the numbers. Okay, in your formula, next thing we need to cover, the stuff under the square root is what's called the discriminant. If you take the square root of a positive number, you're going to get two different answers, plus and minus the square root of 16, 4, or negative 4. You're going to have two different answers there. If you take the square root of 0, that's only 0. And if you take the square root of negative, well, you get imaginary. So you could actually tell how many answers this quadratic equation is going to have by looking at that stuff under the radical sign. If your value of b squared minus 4ac is positive, you'll have two answers. If it's 0, you'll have one answer. If it's negative, you'll have 0 answers. And that is 0 real answers, because we know we'll still have two answers, but they'll both be imaginary. And hopefully, this is not something I want you to memorize. I want you to know why it's true. Okay, so let's go through some problems, and I'll kind of point it out. X squared plus 8x plus 6 equals 0. All it's asking us to do here for each equation, state the value of the discriminant. And I encourage you guys, work out the discriminant first on every problem. It just makes things cleaner, easier. B squared minus 4ac. B squared is 64. Because again, your A, B, and C value, A is 1, B is 8, and C is 6. B squared is 64 minus 4 times A times C. 4 times 1 times 6 is 24. The value of your discriminant is 40. And I'm going to go a step further. I'm going to go ahead and solve that, because I want to show you why that discriminant is important to us. The rest of your formula, x is equal to negative b plus and minus the square root of that over 2a. You see how simple that formula is now. Negative 8 plus and minus square root of 40 over 2 times 1. Since the square root of 40 is a positive, or excuse me, since 40 is a positive number and the square root will yield a positive or negative, this will have two answers. Had that been a 0, you'd have negative 8 plus 0, negative 8 minus 0. That's the same thing. That's the reason when this discriminant is 0, you have only one answer. And when this discriminant is a negative number, the square root of negative is imaginary, you'll have two imaginary numbers, or imaginary answers, complex answers. So with this again, the square root of 40, let me point something else out. Had this square root been a number like 36, 49, 64, something you could take the square root of, this would have been factorable. Instead of using this quadratic formula, if you get a number here that you can actually take the square root of, that means your answer is going to be a whole lot simpler. This would have been factorable up here, and this was not the route to go. But let's clean this up. Root 40. Somebody split that for me. What are you going to pull out of root 40? Root 4. Let's split it into the square root of 4 times the square root of 10. Everybody okay with that? There are two different terms on top. There is a single term on bottom, which is a 2. Distribute that 2. Divide by 2, divide by 2 to clean up your answer. Negative 8 divided by 2 is negative 4. You cannot divide a radical by a number, but you can divide 2 by 2, which gives you a 1. So your two answers, negative 4 plus root 10 and negative 4 minus root 10. Now, if you need to, type that in to your calculator just to make it more real to you, because some people, that's great that you got radicals, but we really don't understand what that means. If you need to type in negative 4 plus root 10 and negative 4 minus root 10, just to make those answers more real to you. Negative 0.84 and negative 7.16. Those are your two answers. I also want to point something else out. We're about to get into the equations of these things again. See, x squared plus 8x plus 6. Let me type that in. X squared plus 8x plus 6. Graph. I just want to remind you again, quadratic equals parabola. When you graph this parabola, it will have two intersection points. We know what those intersection points are. Something else, those two intersection points are what's called irrational. They're not neat decimals. Those decimals continue forever without any type of repeating, terminating, anything. Square root of 40 is an irrational number. Square root of 10 is an irrational number. So your answers are irrational. But I do want to point something out. Parabolas are symmetrical. They have a line of symmetry. There's your line of symmetry. Look at this answer here that we got. Just FYI for future information. Does everybody see the line of symmetry here? Your two answers, negative 4 plus root 10 and negative 4 minus root 10. See if you can picture this. Here's negative 4. One of my answers, I'm going to add root 10 to get. My other answer, I'm going to subtract root 10 to get. My line of symmetry is this negative 4. Do you see it right here? If I went to negative 4, 1, 2, 3, 4. Here's negative 4. That's my line of symmetry. One of my answers is negative 4 plus root 10. So the distance from negative 4 to here is root 10. The distance from negative 4 to here also root 10. So my two answers, negative 4 plus root 10, negative 4 minus root 10. The reason I went ahead and pointed that out is when we do quadratic equations, parabolas, when we study more about their graphs, this is my line of symmetry. Okay, that's my middle point. Okay, moving on. Let's again do the same thing. Start out with b squared minus 4ac. Savannah, help me with what's b squared? Here's ABC. What is b to the second power? Careful, here's b. So 16. And keep in mind, guys, b squared will always be positive. If you get a negative for b squared, it's wrong. If you square a number, it's always positive. And minus, I went ahead and put the minus here that's built in. Scala 4 times a times c. What do you get for 4 times a times c? 20. 16 minus 20, which is a negative 4. b squared minus 4ac in my formula is under a radical. I have a radical of negative 4. You cannot take the square root of negative 4 and get real answers. How many solutions will you have? 0 real. But you will have 2 imaginary. Let's go ahead and find them. So where will this cross? It won't. And I'll show you the graph here. 5x squared minus 4x plus 1. 5x squared minus 4x plus 1. Graph. Should have no intersection. Yeah, see, you can zoom in, but that does not cross the x-axis at all. It nearly does. And we see that since this is so low, that's the reason we know that it's pretty close to crossing. Had this been, which, by the way, well, let's go ahead and plug it in. I'm talking too much. X equals negative b. Here's b. So negative negative 4, which is positive 4, plus and minus the square root of junk, which is up here. over 2 times a. There it is plugged into your formula. And you see, this is the hardest part of your formula. That's the reason, again, work it first. That's what goes under the radical. So you have 4 plus and minus. The square root of negative 4 can be split into the square root of 4 times the square root of negative 1, which is 2i over 10. 4 won't divide by 10. 2 won't divide by 10. You can do 10 divided by 2. Read it from top to bottom, though. Let's split it into two separate problems. 4 over 10 gives you 2/5. Plus and minus. 2 over 10, that's an I right there. 2 over 10 gives you 1/5, and you do have an I. You have two complex answers. Next problem. It says in tennis, a lob can be used to buy time to get into position. The approximate height S in feet for a tennis ball that is hit straight upward at V0. We're getting, let's talk about this. We're getting into some physics now. Those of you that have taken physics or have to take physics. V0 is what's called initial velocity. That's your starting velocity. That's how hard or how fast something takes off. So you have an initial velocity of V0. You have an initial position. Okay, S0 is position, or in this case, it's going to be our height. That's the height that you're hitting it from. And this negative 16t squared involves entirely with gravity, and that's acceleration due to gravity is where that comes from. That's a constant. So anytime you have any kind of projectile motion, you're shooting a missile, you're hitting a tennis ball, you're shooting a basketball, all of those things have parabolic paths. Okay? So in tennis, a lob can be used to buy time for position. The approximate height, S, in feet, which is your, instead of y equals, we have S equals, is modeled by this, where t is time in seconds. Use figure 1.56 to estimate the time it takes for a ball to return to the court when it is hit straight upward, which is kind of crazy because I think it would come down on your side if you hit it straight upward. When it is hit straight upward with a velocity of 60 feet per second and a height of 5 feet, or from a height of 5 feet. So here's your equation. The height is going to equal negative 16t squared plus initial velocity of 60 feet per second from a 5-foot height. And what they've done, they've actually taken, they graphed this. Anytime you have a negative t squared or negative number x squared, it's always going to be an upside down parabola. So really, this will always be, it should make sense. If you're talking projectile motion, it'll always be an upside down parabola. Looks like it's going to take nearly 4 seconds for it to hit. To actually find out how long it takes, let's use quadratic formula. You can try to factor it. Let's say move that negative 16 over. You're going to get add to give you 60, multiplies to give you 80, negative 80. I don't know. There's not going to be anything that exists. So quadratic formula. Always start with b squared minus 4ac. So b squared minus 4 times a times c, which is, I believe, negative 320. Minus minus makes it a plus, which gives you 3,920. That's b squared minus 4ac. And again, once you find that, the rest of it's pretty easy. Your formula, which instead of x equals, I'm going to put t equals negative b plus and minus the square root of junk over 2 times a. This is real close. Don't start trying to simplify this. Okay? Our answer is going to be in seconds. Our answer is going to be a decimal anyway. Why in the world, unless they just ask you for an exact answer, don't start trying to simplify it, because I want a decimal answer, because if I get an answer like root 3 seconds, you know, what does that mean? I'd rather have my answer in like 2.8 seconds or 9.7 seconds, right? So let's not give a weird answer like that. Here we go. I have two answers. My first answer is negative 60. Might want to put this in parentheses. Negative 60, because you want the whole top divided by the whole bottom, plus the square root 3920 divided by, well, I need a closing parentheses, divided by negative 32. And I get negative 0.08. Which that should have been, no, okay. And then I've got the exact same stuff. Let me teach y'all something about your calculators real quick. I don't want to type all that in again. Because on these problems, you've got to do negative 60 plus that junk, then you got to do negative 60 minus that junk. Right above your enter key, there is something called entry. It's in yellow. Instead of typing all that in again, what I can do is hit second enter, and it types it in again for me. And the reason I want it to do that is because all I've got to change is to scroll back up here, and where I have a plus, I just need a minus. Instead of having to type it all in again, and I get 3.8. So it's going to take 3.8 seconds or negative 0.08 seconds for that to hit the ground. Look, here's 3.8 seconds. Where's the negative 0.08 seconds? Well, it's over here. Had that been a real parabola type situation, but we hit it from 5 feet, if you went to the left, it would have hit at negative 0.08 seconds. So if you go back in time, negative tenth of a second, it will hit the ground. Not really. Okay, does that make sense? Maybe. Okay, last thing we're doing today, let's talk a little bit about inequalities. Interval notation and inequalities, and you might have done this last year in Algebra 2. If so, this is pretty easy. Students will discover how to use interval notation of equalities and will solve inequalities and express their answers using interval notation. They will also solve compound inequalities and combine their answers into single interval if possible. Last thing in the chapter. Interval notation is 1,000 times easier to use than what you've used in the past. Instead of the whole x is greater than 3 and the alligator eats the bigger number and all that stuff, much better than that. Or what's really confusing when you have those sandwiches, negative 3 less than or equal to x is less than 5, to where x is between negative 3 and 5. It's bigger than negative 3, smaller than 5, it includes negative 3, doesn't include 5. That's what we're doing. We're going to change that to what's called interval notation, which is much better to use. Okay. Here's what interval notation looks like. Set builder notation, which you've probably talked about, the set of all x such that x is bigger than a number. But interval notation, that's our focus again for this part of the lesson. Interval notation looks like this, to where you have a starting point. If you're talking about all the numbers from here to there, you have a starting point, you have an ending point. If a number is not included, you know, like the old greater than or less than, if a number is not included, we're going to use parentheses. If a number is included, we're going to use brackets. If you didn't know or already know so, a sideways 8, it means infinity. So the first interval notation here is all the numbers from a to infinity. Where a, here's a, okay, all the numbers from there to infinity. Something else you need to know, you cannot include infinity. Infinity is not a number. Okay, so infinity cannot be included in a set. So if you're talking about all the numbers from here to infinity, don't include infinity. It's a concept, not a number. Here you go, maybe this makes more sense. Write an inequality whose solution set is the given interval. This is interval notation. This gives you all the numbers from here to there. If you drew a picture of that, there's negative 9. All the numbers from negative infinity up to negative, that's all that says, would be all the numbers from negative infinity up to negative 9, open circle. Why open circle? Because it's not included. If you see a parenthesis, not included. If you see a bracket, it is included. Okay. Sometimes instead of using the open circle now, they'll use a parenthesis instead. So just in case you see that, that's what that means. If negative 9 is not included, they'll just put a parenthesis on. Oh, I didn't finish that, did I? Write an inequality symbolizing that. Well, that's all the numbers that's smaller than negative 9, so that would be x is less than negative 9. Would be the inequality that goes along with that. All numbers smaller than negative 9. Let's try another one. All the numbers from 0 to infinity. Here's 0. And all the numbers from there to infinity. And notice the bracket there. We're including 0. So So we're going from 0 up to infinity. We're coloring in because we're going forever. Or again, sometimes now they'll use, instead of a closed dot, they'll use this bracket and go from 0 to infinity, and they'll draw it like that. So that would be all numbers, help me out, Avery. All the numbers from 0 to infinity would be all the numbers that are greater than, less than, greater than or equal to, less than or equal to 0. Greater than 0, and since it's included, greater than or equal to. So I guess you can think of the bracket as being like a line underneath. The or equal to, when you include it, put a bracket. Okay? Next one, linear inequalities. So we kind of see the bracket notation now, how to use it, or excuse me, interval notation. Reminder on how to solve linear inequalities. Well, you can solve equations, you can solve inequalities. Okay? Negative 3x minus 9 is less than 0. Let's combine like terms, take that minus 9, move it to the other side. I now have negative 3x is less than 9. This is the only difference, and hopefully you'll remember it. When you're solving an inequality, for those of you that were in ACT review with us the other day, we saw a problem involving this. When you're solving an inequality and you divide by a negative, make sure you flip your symbol. So we're going to move to the other side, divide by negative 3, flip this symbol over. So you now have x is greater than negative 3. Write the solution set in interval notation. All numbers greater than negative 3. Let's draw that. Here's how I graph my number lines. There's negative 3. That's the only one I need. All numbers bigger than negative 3 would be an open circle or a parenthesis at negative 3, and we're shading to the right. All things above negative 3. In interval notation, that'd be all the numbers from negative 3 to where? Anybody? Infinity. That is not a point. That is interval notation. All the numbers from here to here. All the numbers from negative 3 up to infinity. Again, we have linear. A line is greater than a line. Now I do want to, let's graph this. Okay, here's the two graphs. 1/2 x minus 3, obviously, hopefully it's obvious, it would be the one on bottom because it crosses at minus 3, has a slope of 1/2. The blue one, the 1/4 x plus 2 is the one on top, has a y-intercept of 2. And what we're wanting to know is where is this line, okay, greater than. Simply means above. Okay, where is this line above that line? Does that make sense? Where is the red line above the blue line? Looks to be that it starts here. And it's everywhere from there. Hey guys, that number line, it's an x-axis. Everywhere from there to infinity. But what's the issue? What do we know? What do we need to know? Where is there? Right? It looks to be somewhere around 20, I think, when we solve it. But that's what we're looking for. Where is your blue line, excuse me, where is your red line above the blue line? That's what greater than means. So let's try to solve that, and hopefully that'll make sense when we solve it, what the picture actually means. Let's take minus 3, move it to the right. Let's take 1/4 x, move it to the left. Get all your x's together, get all your numbers together. Before we can add those, we do need a common denominator. So let's change that to 2/4. Multiply top and bottom by 2. 1/4 moves to the left side by subtracting. Let's just do that in our head. 2/4 minus 1/4 gives me 1/4. Bring down your inequality symbol. Minus 3 moves to the right side by adding. So you have 1/4 x is greater than or equal to 5. Since 1/4 is being multiplied times x, let's divide by 1/4. I'm just showing an extra step here. We've got to divide by 1/4. To divide by fractions, we flip and multiply. That'll be 5 times 4, which is 20. So we were right there. X is greater than or equal to 20. Graphing the solution set, and again, this is your x-axis. When you're graphing the solution set, you're drawing a picture of your x-axis. Here's 20. X is all things greater than or equal to. So that's what the actual solution looks like. Or you can write it as all the numbers from 20 to infinity. Notice I included 20, but I did not include infinity. You cannot include infinity. It's not a number. It's a concept. Compound inequalities work the exact same way. All the numbers from A to B, not including A, not including B, including both, including A, not including B, and you see there the brackets mixed with parentheses and vice versa. Okay, this B. It has absolutely nothing to do with Auburn. I will throw that out there. Okay? I know it looks like it, but it does not. When you have a U, large U means a union, such as marriage. An upside down U is an intersection. You have unions, you have intersections. A union simply means you're putting two things together. An intersection is you're looking for its overlap. Okay? Union, put it together, intersection, overlap. So let's try this. A is the set of all things from 1 to 5. Let's kind of draw a picture of all three of these scenarios. I need 1, 3, 5, 6, and 7. 1, 3, 5, 6, 7 on a number line. A is all things from 1 to 5. So an open circle at 1, an open circle at 5. It's all the stuff between. Okay, 1, 2, 3, 4, 5, not including 1, not including 5. B is all things from 3 to 7, including 3. So I'm going to do a closed circle here. Let's do it right above it because it's going to be confusing if I don't. B is all numbers from there up to here, not including 7. And then you have C, which I'll do in black, is all numbers from 6 to infinity, not including 6. There's all the numbers in C. So you have three different sets. If I'm looking for A union B, all that simply means is take all the numbers that are in A, take all the numbers that are in B, and put them all together. And just tell what numbers you have now. The numbers in A are the blue numbers, all the numbers from 1 to 5, not including 1. The numbers in B are all the green numbers from 3 to 7. Put those together. And that would be all the numbers from 1 up to where? 7, right? Does everybody understand that? Now you got to, here's the hard part. Do you include them? Do you not include them? Okay, put all the numbers from A together with all the numbers from B. Do you have a number 1 in either one of those sets? No, don't include it. Do you have a 7 in either one of those sets? No. The blue one runs up to 5. Obviously not a 7 there. The green one runs up to 7 but does not include 7. So A union B would be all the numbers from 1 to 7. That's it. Next one. We're looking for the intersection of A and B. The intersection of two sets is simply the numbers that are included in both. It's where they cross. Okay? The intersection of A and B, well, here's A. Again, starts at 1, goes up to 5. B starts at 3, goes up to 7. So you have an intersection point here in the middle. Here's your points of intersection. And again, the same question. The hard part is, okay, what's included, what's not included? My intersection, let me not put that. My intersection would run from 3 to 5. And again, for there to be intersection, the number must be in both sets. Blue is all the numbers from 1 to 5. Green is all the numbers from 3 to 7. Is the number 3 in both sets? What do you think, Lydia? Is 3 in both sets? Is 3 in the blue set and the green set? Yeah, because blue, it obviously includes 3 here because it's in the middle. And since it's a solid circle, it's also in the green, so we put a bracket. Now, the number 3 is a member of the intersection. The number 5. Elizabeth, what do you think about it? It's in the green set, obviously, because the green is all the numbers from 3 to 7. So, yeah, 5's in it, but is 5 in the blue set? Open circle means not included, right? So 5 is in one of them, but not in the other. So the intersection will be all the numbers from 3 to 5, including 3, not including 5. Any questions? Not included. Yes, open circle not included. Next, let's do the union of A and C. A was all the numbers from 1 to 5. C was all the numbers from 6 to infinity. So you're putting all these numbers with all these numbers, all the blue numbers with all the black numbers. Here's the only way that you can write that, guys. That's all the numbers from 1 to 5 put with all the numbers from 6 to infinity. There's really no way to simplify that. Now, that would be, think of it like this, that would be all the numbers from 1 to 5, skip all the numbers between 5 and 6, and skip to all the numbers from 6 to infinity. Okay. And the last one, the intersection, or no, yeah, last one. The intersection of A and C. Okay. Brianna, where do those intersect? A is the blue one. C is the black one. What numbers are members of both? None of them. That is an empty set. There's nothing that exists in that set. Okay? There's no overlap. If there's no overlap, then we put that. Now let me give you one more. Let me point something out. If you had all the numbers from negative infinity up to 7, and I ask you to join that with all the numbers from 4, let's do a bracket, all the numbers from 4 to infinity, kind of the other scenario. Again, union, you're uniting the two. You're putting them together. Put all those numbers together. Anybody want to share with me what numbers you now have? All of them. Okay? If you took all the numbers from negative infinity to 7, and then all the numbers from 4 to infinity, that's every number. Okay? Some numbers you even have duplicates. We don't care about duplicates. Okay? Just don't even worry about duplicates. The union of these two sets, you can write one of two different ways. You could put all real numbers. That's every one of them, not imaginary. That's just the real ones. Or you could write it as all the numbers from negative infinity to positive infinity. So anytime your answer is all real numbers from here on out, you could write it this way. All the numbers from negative to positive infinity. Okay? Okay, next problem. 2x minus 3 is greater than 5, and 4 minus x is less than or equal to 3. We solve each. First step, let's move minus 3 over by doing plus 3. We're going to have 2x is greater than 8. Divide by 2, you have x is greater than 4. And here's how I solve this. Anytime I see just plain negative x, I always move it to the other side. And if I'm going to do that, I'm going to move my 3 to the side. Bring down my symbol. Negative x, when I move it to the other side, will become positive x. That's why I did it. 3 will become minus 3, so let's subtract 3 from that. It gives me 1. We always like for our x to be first, so that would be x is greater than or equal to 1. Okay, now let's talk about that answer. Let's talk about the word and. And you've probably heard this before, but what the word and actually means. You go to an amusement park, and in order to ride a ride, you must be, for some reason, 15 years old. And 6 foot tall. That's a major ride right there. You must be 15 years old and 6 foot tall. Does everybody understand what the word and means now? And hopefully you did in the past. You just probably never gave much thought. The word and means you meet both requirements. Okay. Well, hang on a second. Isn't there a connection with and what we just talked about? And is an intersection. Right? It's kind of like, think of it like this. It's like an A, like and. That upside down intersection symbol simply means and. Okay? This and this are both true. It's a member of this set, and it's a member of this set. So in order for and to be a true statement, it must meet both requirements. So an and is an intersection statement. So let's look at this one. And there's a good possibility you can do this in your head without showing all this work. Here's 1, here's 4. So x is greater than 4, looks like this, and, let's do it in black, x is greater than or equal to 1. Did you see the overlap? Did you see the intersection? What numbers are bigger than 4 and bigger than or equal to 1? All the numbers over here. Pretty much, again, if you see that word and, you're looking for the intersection of the two groups. That would be all the numbers from 4 to infinity, correct? Do we include 4? Is 4 a member of both sets? It is here. It's bigger than or equal to 1, but is it greater than 4? Do not include 4. So the solution set, the set of all solutions would be all the numbers from 4 to infinity. That was an intersection problem. And anytime you see that and, if you just want to shorthand it and put that intersect, that's fine. Good question. Good question. Right here, should I not have flipped it? Okay, let's solve that again. Let's do it the other way. 4 minus x is less than or equal to 3. If you multiply or divide by a negative, you flip your symbol. The way I worked it, I didn't multiply or divide by negative. I moved negative x over. I moved my term over. Okay? Now let's solve it the other way. Subtract 4, and it gives you negative x is less than or equal to negative 1. If you solve it that way, you do have to divide by negative 1, and you would flip it. And you get x is greater than or equal to 1, which is the same answer I got. X is greater than or equal to 1. But the way I solved it, instead of dividing by negative, I took negative x to the right side, I took 3 to the left side. And make sure that you can do this. If 1 is less than x, if you want to put that x first, guys, the alligator is eating the x. Okay, remember the old, the chicken's pecking the smaller number, the alligator's eating the bigger number. If the alligator is eating the x here and you want to write it first, make sure the alligator continues eating the x because it is larger. Okay. Last problem. Let's do an or, then I'm finished. An or statement, okay, since and was an intersection, or would be a union. Because an or says it could meet this requirement or this requirement. It could be a member of this set or this set. Let's just put them all together. Okay. So this is a union problem. We solve each of them. Let's go ahead and do minus 4. Gives me negative 3x is less than negative 6. Divide by negative 3. Make sure you flip your symbol over. X is greater than 2. Union. Let me just make sure in the past we had to distribute this, right? Guys, since 3 has been multiplied by the whole side, just divide it. Instead of using the distributive property, just divide by 3. And that'll give you x minus 2. Since it's positive, you don't have to flip. Minus 2 turns into plus 2, gives you x is less than or equal to 0. So your answer is all numbers bigger than 2 or all those numbers smaller than or equal to 0. So it looks like this. Here's 0. Here's 2. All the numbers, not including 2. All the numbers from 2 to infinity. Or all the numbers smaller than or equal to 0. That would be all the numbers from negative infinity up to 0, including 0. Union all the numbers from 2 to positive infinity. Those are the solutions. Pretty much every number except for these is the solution to this compound inequality.